Today we're going to make things a little bit more difficult, a little bit more complicated. If you notice, our first problem has a 3 here, and usually there is no number there, which means it's a square root, so there's that invisible 2. Well, our title is Simplifying Radicals. Well, we're simplifying radicals with indices larger than 2. And it takes a little bit more guess and check, a lot of calculator work. Is going to be pretty helpful for you. Now, the same properties apply though. If I have a cube of a cube root, they essentially simplify each other out, and I'd end up with just what's underneath that radical sign. So I end up with that 10x. Now I take a look at a situation like this. I have the cube root of 27. Well, remember, if we had the square root of 16, you're thinking of what two numbers, or what number multiplies by itself to get 16. Well, 4 times 4 is 16. So that's where the square and the square root comes into place. So we want to ask ourselves, is there a number out there, one number, that multiplies by itself 3 times? Well, I think about 27, and 3 times 3 times 3 gives us 27. Well, I can look at that as the cubed root of 3 to the 3rd. Well, a cube and a cube root cancel each other out, so we're left with 3. Because 3 times 3 times 3 gives us 27. Now, we can have negatives when we have indices that are odd. Because if we take 3 negatives and multiply them by each other, we end up with a negative. With square roots, you can't, because if you take 2 numbers, or a number times itself twice, if it's a negative number, it becomes a positive. So we can have those negatives. So in this case, I need to think about what number times itself 3 times is negative 64. Well, negative 4 to the 3rd power is negative 64. And a cube root and a cube are going to cancel each other out, and we end up with negative 4. Because negative 4 times negative 4 times negative 4 is negative 64. So let's think about the 5th root of negative 96. Well, if some of you who have fancier calculators might allow you to do the 5th root of 96, and we're not going to end up with a pretty number, because there is no number multiplied by itself 5 times that gives us negative 96. So what we want to do is we want to try to come up with the greatest fifth power that is a factor of negative 96. Well, usually I like to suggest that you work with 2's and 3's, because a lot of times you're going to have 2 to the something or 3 to the something and then multiply it by one more number to get you to that number. Well, I'm going to help you out with this one. Change my color. I'm going to have the 5th root of, I know that if I take negative 2 to the 5th power and then multiply that by 3, I get negative 96. So 5 negative 2's times 3 gives us negative 96. Now the reason I need to define something with a 5th power was because we know a 5th power and a 5th root are going to simplify each other. Which means since this has 5 negative 2's in it, that negative 2 gets to come on the outside. But we still have this 5th root of 3 left over. So I have a 5th root of 3. So the square, or the q, or the, let me get the right index, the 5th root of negative 96 would simplify to negative 2, 5th root of 3. And that happens when you don't have anything perfect. And this is what I was talking about. It takes some guess and check and some working with to try to find numbers that multiply to this radicand.